Hello, my dear children. In exercise 5.1, we have discussed the continuity of a function at a given point. Okay, my dear children, we have solved some questions also in exercise 5.1. Now, come to exercise 5.2. In this exercise, we are going to discuss about differentiability, differentiability of a function at a given point. We discuss this point and the derivative of composite functions by using chain rule. We discuss these points. These are the concepts we discuss for the exercise 5.2. Okay, my dear children? Right. In 11th class, you have studied the derivative of a function f. Suppose f is a real function and c is a point in its domain. Then derivative of f at c is defined by f dash of c. We read this symbol as f dash of c. That is equal d by dx of f of x at x is equal to c. It is given in the first year. It is defined as h tends to 0, limit f of c plus h minus f of c whole divided by h, provided this limit is a finite number. This limit compulsorily exists, provided this limit exists. This is called derivative of f. Okay, my dear children, here d by dx is called differential operator. Remember this point, my dear children. If we are differentiating with respect to x, then differential operator is d by dx. If we differentiate a function with respect to theta, then d by d theta is called differential operator. Okay, my dear children, if y is equal to f of x, then its derivative is denoted by dy by dx or d by dx of f of x or y dash. These are different notations. Okay, my dear children, the process of finding derivative of a function is called differentiation. What is meant by differentiation? The process of finding derivative of a function is called differentiation. We also use the phrase differentiate f of x with respect to x to mean find f dash of x. Okay, my dear children, we use the sentence differentiate f of x with respect to x to mean find f dash of x. Understood this point, my dear children? Right. Now come to the next point. Differentiability of a function at a point. What is meant by differentiability of a function at a given point? See here, let f of x be a real valued function defined on an open interval a comma b, and let c belongs to open interval a comma b. C is a point lying between this interval. Then f of x is said to be differentiable or derivable at x is equal to c if and only if, as x tends to c, limit f of x minus f of c by x minus c exists. If this limit exists, if the limit is a finite number, then we can say that f is differentiable at x is equal to c, or f is derivable at x is equal to c. This limit is called derivative or differential coefficient of the function f of x at x is equal to c. Okay, my dear children, therefore f dash of c is equal to, as x tends to c, limit f of x minus f of c by x minus c. This limit also can be written as h tends to 0, limit f of c plus h minus f of c by h. Both denote the same limit. Understood, my dear children? Right. If as h tends to 0, limit f of c plus h minus f of c whole divided by h does not exist, then we can say that f is not differentiable at c. Previously I told you, if the limit exists, then the function is said to be differentiable at x is equal to c. If the limit does not exist, then we say that f is not differentiable at x is equal to c. In other words, we say that a function f is differentiable at a point c in its domain if first, as x tends to c minus limit f of x minus f of c by x minus c. This limit also can be written as h tends to 0, limit f of c minus h minus f of c by minus h. This limit is called left hand derivative. Left hand derivative of f at x is equal to c. Okay, my dear children? Right. And second one, as x tends to c plus limit f of x minus f of c by x minus c. This limit can be written as h tends to 0, limit f of c plus h minus f of c by h. This limit is called right hand derivative of f at x is equal to c. Then both should be equal. It means left hand derivative of f at x is equal to c should be equal to right hand derivative of f at x is equal to c. Both left hand derivative, LHD stands for left hand derivative of f at x is equal to c, should be equal to RHD. RHD stands for right hand derivative of f at x is equal to c. So left hand derivative of f at x is equal to c is denoted by f dash of c plus. Okay, my dear children, f dash of c minus f dash of c minus is equal to, as x tends to c minus limit f of x minus f of c by x minus c. Now right hand derivative of f at x is equal to c is denoted by f dash of c plus, that is equal to, as x tends to c plus limit f of x minus f of c by x minus c. These are called left hand derivative and this is called right hand derivative. These two limits must be equal, then only the function is said to be differentiable at x is equal to c. Understood this point, my dear children? Right. Now come to the next point. A function f is said to be differentiable in an interval, closed interval a comma b, if it is differentiable at every point of closed interval a comma b. In an interval, f is said to be differentiable. If the interval is a closed interval, then it should be differentiable at every point of the interval. As in case of continuity, at endpoints a and b, we take right hand limit and left hand limit, which are nothing but right hand derivative and left hand derivative of the function at a and b respectively. Okay, my dear children? In the case of interval, we have to take at endpoints right hand derivative and at the other end we have to take left hand derivative. Okay, my dear children, they should exist. There should be a finite number. Okay, my dear children? Right. Similarly, a function is said to be differentiable in an open interval a comma b if it is differentiable at every point of open interval a comma b. This is about differentiability of a function in an interval. Okay, my dear children, is it clear? Now come to the next point. If f is differentiable at a point c, then it is also continuous at that point. If a function is differentiable at a point c, then we can say that it is also a continuous function at that point. Now come to point 5. Every differentiable function is continuous. Every differentiable function is continuous, but we should note that the converse of this statement is not true. The converse of this statement is not true. That is, every continuous function every continuous function may not be differentiable. For example, f of x is equal to mod x. If you take this function, it is continuous at 0, but it is not differentiable at 0. Okay, my dear children, is it clear? Right. Now come to the next point, sixth point. The following rules were established as a part of algebra of derivatives. You have already learnt in class 11. See here, d by dx of f of x plus g of x is equal to d by dx of f of x plus d by dx of g of x. We can find derivative separately if plus is there between two functions. Similarly, if minus is there, we can find the derivatives of the functions separately. D by dx of f of x minus g of x is equal to d by dx of f of x minus d by dx of g of x. Now come to the third. D by dx of f of x into g of x is equal to f of x into d by dx of g of x plus g of x into d by dx of f of x. This is called Leibniz rule or product rule. You have already studied in class 11. Okay, my dear children, right. Now come to the next point. D by dx of f of x by g of x is equal to g of x into d by dx of f of x minus f of x into d by dx of g of x whole divided by g of x whole square. This rule is called quotient rule. You have already learned in 11th class. Okay, my dear children, right. Now come to the next point. The following are derivatives of some standard functions. You have already learnt these derivative formulas. We use these derivative formulas in this class also. So you should learn well these formulas. See here, d by dx of x power n is equal to n into x power n minus 1. D by dx of x is equal to 1. D by dx of root x is equal to 1 by 2 root x. D by dx of 1 by x is equal to minus 1 by x square. D by dx of e power x is equal to e power x. D by dx of a power x is equal to a power x into log a. Next, d by dx of log x base e is equal to 1 by x. Okay, my dear children, these are all the derivatives of algebraic and logarithmic functions. Okay, my dear children, right. Now come to the derivatives of trigonometric functions. D by dx of sin x cos x, d by dx of cos x minus sin x, d by dx of tan x secant square x, d by dx of cot x minus cosecant square x, d by dx of secant x into tan x, d by dx of cosecant x minus cosecant x into cot x. These are the derivatives of trigonometric functions. My dear children, you should learn all these formulas well to solve the sums, to find the derivatives in the upcoming exercises. Okay, my dear children? Right.